So in reviewing for chapter 10.1 quiz, first of all, combinations, order does not matter. So it would be like you have 10 candy bars and you're picking 7. Order does not matter, okay? But if you were looking for president, vice president, and treasurer, permutations matter. Permutation is because rank matters, okay? So, real quick before we go on, is that with a combination you can use this formula, but to me this is easier because what you do is you pick, because this tells you how many slots on top and bottom you need. Okay, so if you have a total starting at 9, you go down 9, 8, 7, 6. There's 4 slots there. On the bottom, you're going to divide by 4 slots again, starting with 4. 4, 3, 2, 1. On this one is the same thing. 9 with 5 slots. So 9, 8, 7, 6, 5. And then 5, 4, 3, 2, 1. So you can cancel out the 5s. With the permutation, you're not having a denominator this time. You're only thinking about the top part of the equation here. So 9p4, like 9c4, you're going to have 9, 8, 7, 6. But it does not have a denominator. Okay, I'm going to read through some of these and you guys tell me if it's a combination or a permutation. Number 1, in a race in which 6 automobiles are entered and there are not ties, in how many ways can the first 4 finishers come in? First place, second place, permutation. So when you're picking first place, second place, third place, fourth place, order matters. So it's a permutation.
So it's not choose?
No, not choose. Okay, number 20. The model of the car you are thinking of buying is available in 9 different colors, 3 different styles. How many ways can you order the car? This is a trick question. This is called counting principle. It's neither. Okay? So let's write this out real quick. Accounting principle. Okay, this is from way back. You guys should know this for the final anyway. Okay? Accounting principle is where you're multiplying all the possible choices together. Okay, so like this one, the model of car you're buying has 9 different colors and 3 different styles. So 9 times 3 is 27. That's accounting principle. Okay? All right, number 21. A book club offers a choice of 8 books from a list of 40. In how many ways can a member make a collection? Combination. Order does not matter in this. Okay, number 22. A medical researcher needs 6 people to test the effectiveness of an experimental drug. If 13 have volunteered for the test, in how many ways can 6 people be selected? Combination again. Okay. 23. From a club of 20 people, in how many ways can a group of 3 members be selected? Combination. From the 30 pictures I have bought of my daughter's first birthday, my digital picture frame will hold only 3 at a time. How many different groups of 3 pictures can I? Combination. But what if I wanted to fill the 3 places with my favorite, best smile, best smashing of the cake? That's a permutation. So you're putting a value on it. Anytime you put a value on one of these, it's a permutation. Okay? Number 25. A popular brand of pen is available in 3 colors and 4 tips.
No, that's CP.
That is CP, counting principle again. Okay? Let's look at these 2 examples. The company Siesta has 10 members on its board of directors. In how many different ways can it elect a president, a vice president, secretary, and treasurer? First of all, yes. Yep, permutations. Okay? So this is going to be 10p. Actually, not 3, but how many are we picking? 4. Okay?
It would just be 10 times 9 times 8 times 7.
4 slots. Right, so it'll be 10 times 9 times 8 times 7. Exactly.
And then you just multiply that?
And you multiply it, and that's the answer.
The next one's combination.
Number 2. You are on your way to Hawaii, and of your 15 books, your parents say you can only take 10. How many different collections of 10 books can you take? It's a combination. Order doesn't matter. You're not like saying you have to pick your ranking of best book to your least favorite book. If it said favorite book in order of ranking, then it would matter. You're placing a value.
What if they just said like favorite book? Then
Yeah, no, this time, and that's what it did say,
if
actually.
it's like you can only take your 10 favorite books. Then
Yeah, maybe you have a total of 15 favorite books equally favorite. That's what we're assuming they're all equally favorite here, okay? So, so that's going to be 15 choose 10, right? So if I were going to actually do this now, this is kind of interesting. We have 10 slots, correct? Yeah. So we have 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10 of them, right? Over, now we're going to go 10 down. 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now, that's exactly how I set it up before, except there's a lot of numbers there. What can I cancel out? 10 through 6 on both top and bottom, right? Okay, so then you multiply the top and divide by the bottom.
So, like, when you use the formula, you get the same kind of, like, but it's a different way.
Yeah, yep. Okay. All right, so that's combinations and permutations. Now, I want to look. Okay, so this is Pascal's triangle. And remember, when we're doing binomials and we're multiplying them out, these numbers that we have on the triangle itself helps us find the coefficients of those numbers. So, for instance, if I'm multiplying out x plus y to the third, I can write that out by going down to the third row. This is row 0, 1, 2, 3, 4, and 5. So I'm going down to this row right here. Okay, that's the third row. So I can write this out as 1x to the third, there's no y there, plus 3x squared y to the first, plus 3xy squared, plus y to the third.
oh, I get that.
Yeah. Can you explain it again?
Is you might have something like this. Where is 9C5, row and entry on Pascal's triangle? Okay? So already you know it's in what row? Ninth row. Okay? And what entry are you going to go in? 5. Yeah, you're just moving in 5.
So it'd be 1, 9, 36, 84, 126.
Yeah, okay, but what if you wanted to know, okay, so now we know it's in row 9, entry 5 in, okay?
The same formula.
You can use the formula, this formula,
Yeah.
to find it. So it'll be 9 times 8 times 7 times 6 times 5, because there's 5 slots. 5 times 4 times 3 times 2 times 1. That's going to be the coefficient at that spot.
Okay, so the fifth number, not like the first 5 terms. All
Right.
combined.
The fifth number in. Okay?
So then,
Okay, these are ready.
Okay, so use the binomial theorem to find the coefficient of x to the fourth in x plus y to the seventh.
Oh wait, can I try it?
Okay? So before we go on, we know that it's at what row? Seventh row. So 7C, oops, sorry. 7C, and what's this one going to be? 4,
And
okay?
then you just plug it into the equation.
So I'm going to plug it into the equation, so it's going to be 7 times 6 times 5 times 4,
how do you know it's 7?
because we're starting, because this is at 7th power.
Oh, I
Okay.
didn't see that part. Oops.
And then you're going to go down 4 times 3 times 2 times 1, and guess what cancels out there?
4.
The 4s, okay? So multiply that out. I don't happen to have a calculator. I need one of you guys to do that real quick for me.
Because 4 plus blank what equals 7?
So what we just found was the coefficient for x to the fourth. And the reason why we know it's 4 is because it says it right here, the power is 4, but the total power is 7. So we're looking at C7, C4, okay? And that will give us our coefficient. So we already know it's x to the 4th power, that goes there, and it's going to be y to whatever's left over from 7 minus 4, which happens to be 3, okay? Now, notice that this is in general terms of x plus y to the 7th. In your homework from section 3, it gave you this question, x minus 3 to the 7th. Find the coefficient. Well, once you get it in terms of this, you can replace the x and y with these. This is an x, and then the minus 3 is a y. So I'm going to take 35, the x's stay the same, correct? And then the y's are going to be negative 3 to the 3rd power. Because we don't have a y there. We have something else. We actually have a number. This is the grouping thing, except they're just wanting to find one thing. So if you plug that into your calculator, negative 3 to the 3rd is going to be negative 27. So negative 27 times 35, I don't know off the top of my head what that would be. One of you guys can find that for me. I don't either. So negative 945. So this was wanting to know the x to the 4th of this particular one.
So do we know that negative 3 is 1?
Yep. Oh, in. That's not ln. In. Instead of this one, we're using this one.
Because isn't the top of log?
No, we're not doing ln at all. This is not log. This is just saying the word in.
We take it.